Thank you for coming. I will talk about Helidon and AI. We will be building some intelligent applications with Helidon. And my name is, it doesn't work, okay. My name is Daniel Katz. I work as a Helidon developer. I have also another core Helidon developer remain here. He will help me answer the tough question at the end. Oh, how it works. This is the safe harbor. You saw it several times already today, right? So I don't have to explain it. And this is the agenda. First, we will do a quick Helidon introduction. So for those who haven't heard about Helidon yet, what it is and what's so cool about it. Second, we will take a look at using AI in Java, little in general. So of course, we will be talking about the LangChain4j, right? Then what is a new with very fresh release of Helidon we have. It's just a few days old. And after that, we will take a look at LangChain4j integration in Helidon. This is the new thing. Then I will do a short demo. So you can see how fast we can set up things with Helidon and make the AI application running. And if you have a time at the end, we will take a look at the GenAI and how you can use it in Helidon, the OCI GenAI. How many of you have used the OCI GenAI? No one yet. So we will see how it works. Cool. So let's introduce Helidon. What is Helidon? The simplest way how to introduce Helidon is that it is a microservice framework. Our main competitor is Spring Boot, of course, so it describes it best, right? It's a web server built to play really nice with Kubernetes. It's completely open source. You can find all our source codes on GitHub. You can even contribute if you want to. Unlike with the Spring Boot, Helidon keeps the number of third-party libraries as low as possible. This is very important for us because we have a lot of corporate users. So if you create a Helidon hello world, you won't download half of the universe, just to print it out. And you can choose the right flavor of Helidon. We have 2 of them, and we'll get to it really quickly. We do provide 3 ways of packaging Helidon out of the box. The first one, the default one, is a thin jar. That's a very small application jar with just your business logic in it. And then you have a lib folder with all the dependencies in it. So you can really nicely layer your Docker image, and you don't have to push the whole thing each time you change few lines in your business code, into the remote Docker repository. You will be pushing just the layers which have changed. Then we have really nice support for JLink image. Even with the quick start in Helidon, you even get the prepared Docker file with it and how to nicely do it. That allows creating minimalistic, custom-tailored Java runtime just for your application. It understands the JPMS modules and does a tree shaking of that JDK based on it. So you cut off all the things you don't really need. And by the way, Helidon is fully compatible with JPMS modules, so it works really nicely with JLink. I did a small measurement for you with our quick start hello world, and I got to 74% size reduction. So when I count together the JDK and the 4 megs of the application, it's around 340 megs. I got the 88 megabytes. The final, package which was runnable. Out of that, the 61 was the JDK, which was without all the stuff you don't really need because it was tree shaken away. 4 megs of the application, of course, and 23 megabytes of context data sharing archive, which allows your application to start faster with better performance right after the start. Third option in packaging we have prepared out of the box for you is a Graal VM native image. We have really great support for it, extensive in Helidon. You can create a native binary with super fast startup time. They have more advanced reshaking there. It's not based on the modules, so it will cut even more code, even from your application, which you ordered that code you don't use. So you can really reduce the size of the resulting binary you want to run somewhere in your Docker. With my example, I got to 88% size reduction. So from those 340 megs JDK plus my small application, I got to 41 megabytes. And that's all. You don't, again, like with the JDK image, you don't need additional JDK to run that in your Docker container. So in your Docker container is only the binary, and it's run this it's 41 megabytes. It's super small. Helidon also supports the IoT optimization. We support all three of those main guys out there, right? So, we have extensive support for the native image, of course. So you can get up to 40 times faster startup. That's what I measured. We support Helidon. I say support. We don't have to really support it because Helidon works really out of the box with any Java application. That's kind of really cool thing about it, that you don't need to do any special treatment for it. It just works. So with my small example, I got almost 3 times faster startup. You get instant performance. You can do a warm-up in advance, run against it some workload and save the state. And then you have peak performance right after the start. So you can even prepare your Docker image in a way it's already pre-warmed. But you have the full-blown JDK after that. So you have just-in-time compilation, unlike with the Graal VM native image. And you don't have to do any code optimizations. And newly, since the 4.2 release, which is 2 days old, we have also support for the crack. That's the coordinated restore at checkpoint thing. This is also very cool. It's based on the CRY. You know it from Linux. You are usually using it with Docker and everything. When you make something sleep, it's using that. So you can actually snapshot the running JVM and restore it later. And this is really cool. You can again, you can do warm-up, to get the peak performance after the start. And I got the 30 times faster startup. You get instant performance. And you also have just-in-time compilation available because it's a normal JDK after you restore it. But you have to be careful if you are moving those things, between different architectures. The Graal and Crack just won't work there if it changes because obviously it's optimized for something else. I promised the flavors. We have 2 flavors of Helidon. We have Helidon SE, that's the micro framework. It's no magic, no injection, pure performance. And you are using builders and lambdas to wire things together yourself, so you have complete control of everything. And it's super fast. But you have to be, careful when you are tuning things up. But if you want to go a little more business, you can use Helidon MP. That's annotation-driven. It implements all the specifications, all those specifications from Jakarta, like CDI or JAX-RS. It implements a lot of microprofile specifications, the whole umbrella plus something more. And it's very easy to use. So if you want to concentrate on your business code, you can use the MP, and it will do all the nice things, all the wiring for you. But in Helidon MP, you are still using the Helidon SE under the hood. We are using it, behind all that niceties. There is still Helidon SE powering things up, so that's very performant. We have our own web server, which is built from ground up on the virtual threads, so there is no netting, nothing like that, no reactive stuff. It's all clean, really fast. And the Helidon MP is, in the end, powered by it anyway. So everything is imperative, really simple, and in any flavor you choose. This is a comparison of the actual code. So this is the HTTP get hello world resource. I say resource, the Spring developer would say controller, right? So on the left side, you can see the builder pattern with lambdas. There is the simple get. You can send the hello world back. On the right side, you see the JAX-RS resource. If you ever used WebLogic or any big application server, you know those annotations right there. Pretty straightforward. And we have great integration with WebLogic, of course, because we are backed by Oracle. We are the Oracle team, right? The core developers of Helidon. So we have certified integration with WebLogic over JMS, REST, good old-fashioned SOAP, single sign-on over OpenID Connect, and also the distributed transactions like LRA or XA. We have it certified with Oracle MicroTX transaction coordinator. So if you want to, have your modern microservices running next to the good old WebLogic cluster, you are completely safe with choosing Helidon. Now it's time for the AI, because that's what we will be talking about. So if you know what Helidon is, of course we will be talking about the LangChain4j, right? I can safely say that LangChain4j is the most popular library for using LLMs in Java right now. Is there someone who would disagree with that? No one. Good, awesome. I was expecting some resistance. It's inspired by LangChain for Python. It's also a very popular library there. Like the Python guys are doing the AI very extensively. It brings a ton of cool features abstracted away under really, really nice API. That's like the strength of the LangChain4j is the nice API abstraction. With LangChain4j, you can wire together LLMs, vector stores, vector models, and you can switch underlying vector libraries, and it all works really nicely and seamlessly. Again, the API is the main strength there. We can take a look at simple chat example. Getting a joke, right? That's the simplest one. With OpenAI, so you can see that that the highlighted part is the only part which actually relates to the OpenAI. The rest of it is the business code. It doesn't change if you decide to change the LLM provider. Also notice the demo token. That's not a mistake. That's a feature of LangChain4j for the OpenAI. They are actually having special proxy over which is the call to the OpenAI rerouted, and for the demo purposes, they have some special quotas there, and you can use only GPT-4o mini, and you can use this demo token, which is really cool because I can show you all the nice things today. So this is how you ask OpenAI for a joke. We can also take a look at something more complicated. If you ever used tools thing with the AI, some models support it, some of them don't, but it basically lets you to execute it lets the model to execute your code in your application. How it works, because the model is always stateless, so you can see it's pretty complicated communication. You have to, and if you are using official clients, it's usually on you. We will get there shortly. So you can see that you have to actually inform the model about the function definition which you want him to know, to use, right? And then actually send your question, and then the model calls you back, and he instructs you, now you run this function of yours with those parameters and send me back the result. So you send the result, but you also need to send all the messages you already sent because there is no state in the model. So it all goes on, and then he finally responds with the right answer. It's pretty complicated, and you don't want to do that yourself, right? So this is how it does the LangChain4j API. You just create a simple class with your tool function, and you provide it to the assistant. The assistant in the LangChain4j is kind of like a context for your communication with the model. So if you have a chat memory, it's related to the assistant which you got from the API, and you can set up the tools and things like that too. So this is how it's done, and all that ping pong, between the model is actually done by the LangChain4j for you. And you can even switch the underlying LLM provider, and it will still work. So it's really, really nice. I know it's badly readable. I'm sorry for that. I wanted you to see the relief of the code. Not you don't have to really read it all. But notice that the first third of the code is actually a function definition which you have to send. This code is the official OpenAI Java client. So this is how you do it do it with official OpenAI client. You have to send the definition yourself. Then you get the response with instruction to execute your function. So I'm executing it over there. That's the highlighted part. And then I have to send everything back with all the back to the model with all the context, so he can finally answer me. It's not that easy, and I was really trying to make it, fit in one slide. So I spent like an hour to actually, format it correctly and remove all the unnecessary stuff. It was nice. So let's back to the LangChain4j API. It's way simpler. We have a tool function. We provide it to the assistant again. And only the highlighted part is the one which relates to this concrete model, this concrete LLM provider. Now we will try to switch it to Ollama. And only thing that changes is this. Of course, there is another dependency in Maven you have to switch because you have this extra extension for each provider from the LangChain4j. So you switch the dependency and you switch the configuration for the provider itself. But all the business code stays the same, right? It's really, really nice abstraction. So now we covered the LangChain4j. It's really nice. I won't go. There is so much more. There is so much tools you can use and wire together. The embeddings can be done for you. It's really, really, really cool library. Now we switch to the Helidon back. This is the new release of Helidon 4.2. It's just a few days old, so we will go through some features we have. We have like 3 of them, so it will be really quick. And the most important one is the AI, of course. I will start with the crack support. I have talked about it a while ago. That's the coordinated restore and checkpoint thing. It's a super cool feature for the startup optimization. I already showed you the numbers, right? Then there is a Helidon Inject preview. Helidon Inject is a brand new inversion of control functionality we have in Helidon. It's designed for performance, so everything is done on build time. And our LangChain4j integration, which is also new, is built on top of that. It's actually a proof of point of Helidon Inject versatility because you can use it in both flavors, in Helidon SE and MP, and it will work everywhere. It's seamlessly integrated into the CDI, and also you can use it from all those functions and builder patterns you are using with Helidon SE. So the crack. It brings the ability to snapshot the running JVM. You can pre-warm your application and start exactly from that snapshot. Extremely fast. The restoring is like, just it's few milliseconds, really fast. It's very powerful feature for, just imagine that if you have a pods in your Kubernetes and you can actually scale down, and when you are killing your pods, you can save actually the state of the JVM. And when you will be scaling up next time, you can restore them from the snapshots. This is really nice thing to have. With all the JIT optimizations and everything, you have the standard JDK. You can just snapshot it. If you want to know more about this new feature, because it just doesn't fit into my talk, it's such a shame, you can read it in our Helidon documentation, or we have some new articles coming out with the new Helidon release. Next thing is the Helidon Inject. It's also very exciting. It's our build time reflection-less build time wired dependency injection. That wiring is done on the build time, obviously, and by special annotations processor we provide. There is a great difference against other approaches here because we are generating really nicely readable Java code, not the bytecode, but the Java code. So if you get into some troubles and you want to actually, jump with your debugger through our code, you will figure out that the generated code is nicely readable, and you actually find what is going on there. You get all the cool features. If from the dependency, like things like the interception, event scopes, factory beans, post-construct and pre-destroy. And you get it super fast because everything is build time, so in runtime, everything will be working really quickly. It works with Helidon SE again. It won't slow it down because, again, all the hard work has happened during the build time. It works with CDI in Helidon MP, so you can actually inject those build time beans into your CDI beans, into your JAX-RS resources, and it will work really seamlessly. You can create Helidon inject beans once and use it in any Helidon flavor. This is really cool. You can have like a library with those beans and use it even with both Helidons. And what is very important to say, you can use Helidon inject in Helidon SE, but you don't have to. Helidon SE stays the same. It works the same. It's just the optional feature with both, works in both flavors. So if you want to go really nerdy and tweak everything yourself without any annotations, it doesn't mean that you have to do that with Helidon inject. You can go the old way. We can compare it with CDI. That's kind of thing you do with the DI. The main difference is immediately visible. There are no proxies. You just don't need them. There is no reflection. That's very important for the speed, right? And it gets much faster. So it's reflection-free, so it will work very nicely with native image and stuff like that. There is small price to pay, of course. There's always something, right? For completely avoiding the reflection, you can't really do runtime extensions like you would be used to in CDI. So that's the difference, that no runtime extensions are possible because it's all build time, so you cannot really modify it after.
It's basically AOP.
AOP? Yeah. You mean like aspects? Yeah, it's similar. But it's Java code. It's not bytecode manipulation. So now we can jump in the LangChain4j integration that's built on top of the Helidon inject, which we have explained already. So it's one of the first features we have built on top of that. Again, as it is a build time thing, it has no impact on performance, even in Helidon SE, so you don't have to be afraid of it. You create it once, it can be used in both flavors, in the CDI beans, the JAX-RS resources, and so on. Yeah, so here is the example. So we will, again, do the tell me a joke. We did it a few slides before. This time we will create interface annotated by AI service. That's our build time annotation. So it will actually create a service for you. It works similar like the assistant in the LangChain4j API. We will also configure the actual model completely separately. And this is important because we are moving all that provider and model-specific configuration out of the code. So it's completely separated, so you drive it by your configuration, and again, your business code stays on this side, and it just doesn't change if you will decide to switch the models or the providers later. We will take a look at it shortly. And we can also take a look at our tool example. Again, I prepared this calculator service, so you create a singleton service with the tool. The annotation tool is actually that LangChain4j annotation, so it stays the same. You can even reuse it. And this is all you need to do. It will be wired together all automatically, so you don't have to do anything else. It's even simpler than with the LangChain4j API. And what if we want to switch the models or the providers? Again, I will be switching to the Ollama provider. And as you can see in your business model, nothing changes. All you need to change is the dependency for the extension for the actual provider, but it's all configuration driven and your business code doesn't change.
The API key, it's clear text.
Yeah, but it doesn't have to be. It's for the. It will be complicated for. Yeah, you can reference the environment variable. You can get it from some vault. We are supporting the microprofile configuration. We have our own configuration, which has some extensions. You can get the config properties from wherever you want, from Hikari and stuff like that. So you can do it very securely. Don't worry. You can even, we have this placeholder. So if you want to have this demo key for the, I should have used that. And if you try to run it in production, it will actually throw exception that you left the key inside and you didn't use anything safer. Yeah. Thank you. That's a nice enhancement. And if you are configuring the retrieval augmented stuff with RAG, you just configure it in configuration, and it will be in your prompt. It will be actually wired together by LangChain4j. We will just connect the right things together in Helidon for you. So this is everything you need. Yeah, this is how we use a system message. If you don't know what this is, it's how you give the model some context. That's another message you are sending to the model so he knows how he should behave. So you can tell him, like here, that he is a Frank, a server in a coffee shop. If you are planning to visit our hands-on lab, we will be actually doing the coffee shop example there. So we will use this exact thing there. Yeah, and to continue with the RAG, if you want to set up the actual ingestion for your embedding model and your embedding store, I have used here the Helidon injection annotations. You can do it manually, of course, but in Helidon SE. But this is how you actually work with the Helidon injection. So I have created special factories which will create the model and the store I want to use. I can choose whichever I want. And this is where I'm actually doing the injection with Helidon inject. You can see that I get that store and model I have prepared before. I have this singleton bean with which I can start the ingestion when I really want to do it, because it can take some time. It's CPU intensive, so you usually want to gather your data and do it in some time of when it doesn't really bother your customers. Okay, now it's time for the demo. So I will try the switch, which worked just a minute ago. You can see it, awesome. So I'm in my temp folder. There's nothing there. I will use Helidon CLI. That's another thing we have. It's a small CLI program you can download from us, and with that you can initialize a new project. We will do a quick start version. You can see that there is already version 4.2 with all the new cool features. So I will go all the default. I will use Helidon SE. I will do a quick start. We won't be needing any injection. So I will go like that. Here is our nice new project. I will open it in IntelliJ. It will start without any issues. Yeah. Is it readable? Awesome. You can see that there are those packaging options prepared. So you have Dockerfile for JLink, for native image. I would like to show you all that. I just don't have time for it. So I will clean it up a little. All the examples. We won't be testing anything because there's no time for it, right? I will create my own main. And we will clean up dependencies a little. We will use YAML configuration. That's nice. We don't need any health checks or JSON. We will be logging. And let's get rid of everything else. The testing is not necessary. I have templates, so I don't bore you enough. Here it is, dependencies for LangChain4j. So those are dependencies for our integration with LangChain4j's, and a special one for OpenAI provider. And also, because we will be using Helidon inject, we need the annotations processor. We have a few of them. So we can see that there are the main ones which are doing the Helidon services that will think behind the Helidon inject. And there is special one for LangChain4j. That's the one which will create that AI service out of that interface. And that's it. I didn't forget that. Oh, we will be need logging, right? Because LangChain4j uses the SLF4j, so I will add this one, the bridge. Reload everything. I will do a simple main class. We are using the Helidon SE flavor, so you can do everything yourself. Again, I have it templated. So this is the thing. This is all of it. This is how you start Helidon and create. I have HTTP post handler here. It returns only the hello world right now, so it's not really clever AI up yet. You can see that we have set up configuration and logging, and that's everything we really needed. And loaded the configuration into the server so it knows on which port it should start. We can try it out. Has it started already? Yeah. And I will do tell me a joke thing. And it's written, so it's not a really good joke, right? So we will add some AI capabilities. Yeah, first we need the service. We will do a Frank, because Frank is our mascot. That's the bird, you know, in the logo Helidon. His name is Frank, so we'll do a Frank chat service. Yeah. We need the extra annotation, right? So it will be AI service. And we will do it really simply. It will be just a chat message like this. This is all we need. We will need, we also need configuration, of course. And because, yeah, you can see that IntelliJ helped me today, and my template for YAML doesn't work, so I have to find it here. Sorry for that. It's live templates. And I have special ones for JavaOne. This one. Yeah. Config is here. This is it. You can see it's the same configuration we had on the slides. It's really simple. We just use the OpenAI and the GPT-4o Mini with the demo token. Now we can rebuild it, run it. Oh, and of course, sorry. We didn't wire things together because it's Helidon SE. We have to do that ourselves. We won't be sending back the hello world anymore. We will get from the request the actual content. Question. We will look up the services. We will look up the bean with the AI service, our Frank chat service, right? Oh, this is nice. Like this, so I can call the chat directly here, get the response from the model, and just send it back. That's all I will wire together. Now we should get some joke. Why don't skeletons fight each other? They don't have the guts. Okay, it's one of the better ones, actually. Okay. Oh, and we can try something else. We can also, that's me, silly me. We can use a system message to give it some context, what the model should behave like. So I have another template for it, the system message. But this time it's a coffee shop thing. we will make Frank a passionate Java developer who likes to make jokes about Java being better than Python, of course, right? So. Tell me a joke again, this time about Java. Why do Java developers prefer the Sun over Python developers? Because they can't handle the indentation. Yeah, it's that one is weaker. Okay, and there is another thing we can try. Something more, Carol. What is the time now? And this is kind of interesting thing because the models usually don't know what is the time. And, oh, sorry, another error from, thank you, IntelliJ. The model doesn't know the time. He has no state, right? So it's complicated for him. We can fix that with the tool function. So we can add it really easily. I will. New Java class, we will do a time service. Again, it will be the build time bean, singleton, like this. It will be super simple. Local time, almost there. Local time, get current time. We will be not using any parameters or anything to make it simple. Local time now, it can be simpler. And there is a tool annotation. You can see that it's LangChain4j annotation. We will find it for you, so you don't have to wire it yourself. You can disable, of course, the auto-discovery. And we will give it some explanation what it does. Returns current time now. Yeah, it should be all we need. And this time, when we ask about the time, we should get the time, and we get the time, and it's a correct time. It's just Central European time I have on my computer, so trust me, it's correct. With some jokes about it's precise and knows how to handle details, unlike Python, where sometimes the time gets a bit fuzzy. Okay. So this is it. What we can try now is also switching the model. I will start my Docker image with Ollama, so we can start to switch the provider. And I will go into the configuration again, and because my template doesn't work, I just need to do it manually. And I will just replace this part. I don't need to change anything else. And the dependency, of course, yeah, that's the thing. So we will just add JavaOne Ollama dependency. That's another extension. My computer is getting hotter because the Ollama started. And now we can try the same thing. This time we are using Ollama, the model which supports the tools. And it should use my function for getting the time. It's slower, you know. My computer isn't so powerful as the. You can see we got the Central European time again. So it used my function and any other because it didn't know which one to use. So this is it for the demo. I will just.
Why did it drop a joke?
Yeah, because there is this system message, right? We didn't remove it, so it's.
Well, no, there is no joke.
Oh, it's dropping the joke because it's like to make jokes, right? We don't have to ask anymore. It will drop the joke all the time. Yeah. I will just disable the Ollama again. So 4 minutes. Ah, okay. So maybe I will sacrifice the GenAI. I can only show you that if you ever use the official API, you usually have to think about the way how you do the authentication, because you are connecting into the cloud, right? So you have to have keys and everything set up. And if you really want to deploy it somewhere, you never know which kind of authentication you will be actually using. So usually you have to think about that. One time in OCI we'll use the resource principal for functions, then you will need to deploy it in the pod somewhere in the Kubernetes or on some VM with the instance principal. And those are different kinds of authentication in the SDK, in the OCI SDK, if you want to use it for the GenAI. With Helidon, we make it simpler. This is not Helidon. This is how you would done it, without us. That's when we will eventually have some if statements, figuring out if you are production or not. So you can use your laptop configuration or use the actual service somewhere in the OCI service. What we do for you, I'm trying to be really fast, that we actually provide it as a Helidon inject service. So we will figure it out based on the configuration. You can configure it like that. So there is special config separated from the main one. There is a lot of reasons for that, where you can set up the policy, how you want to figure out which authentication to use. So for example, here I have used automatization method for figuring it out. If you want to use instance principal or config file, there is more of them, but you want to limit it so it doesn't take too much time. And you don't have to have any if statements and anything. You can use the session tokens. You can use the configuration directly into your config file, and we will provide it. Again, your business code doesn't change. This is the message I wanted to give you. And we have a conclusion. Sorry for the speed for the last slides. It's those 4 minutes. LangChain4j integration is one of the first features based on the Helidon inject. It provides extra extended integration with some selected supported LangChain components, but you can use all of them. It's just for some of them we have even better features prepared. And the OCI GenAI works great. As you have seen, we have really nice tweaks for you to use. If you want to know more about Helidon, you can find us everywhere. We are on all the social sites like Blue Sky and Twitter or X. Yeah, I have wrong icon there. We have really nice web pages. You can read our Medium articles. We are blogging a lot. We are completely open source. You can find everything on GitHub, even contribute. It would be really nice. We are YouTubing from time to time, and we have a public Helidon Slack when we can help you with any technical issues, if you have one. Any questions?
Yeah, if you had like a big legacy Spring Boot app and you were interested in trying Helidon, can you use like Helidon and then the existing Spring dependency injection, or do you have to completely swap out the whole?
You have to swap it out. I think we had some open rewrite templates, right, for it, so we can help you with that. We also have a pet clinic implemented, so you can take a look how to switch. It's not as bad as it sounds. It's actually easier. And those open rewrite templates can actually help you a lot with switching some larger application. So it's different. If you're using the MP version, it's actually the normal CDI. So if you are migrating between some application server like WebLogic or Glassfish, for example, right, or JBoss, it's really like one-to-one. It's really the same thing. If you want to migrate to Helidon SE, you have to understand that you have to get your hands a little dirtier because you are after the performance, right?
So Spring has pretty much same capabilities. Why should one choose Helidon?
You mean for the AI or?
For a new application, any application.
Because
I consider Helidon instead of Spring.
we are faster because we are based on virtual threads. Also, the lowest version of JDK you can use is 21 right now with version 4. That's because of the virtual threads, of course. We are completely built on top of them. We are using the request threads per request model there, so it's super simple. There is no netty, no reactive madness anywhere. Everything is imperative. and we have really nice performance with it. So you have a really lightweight framework which is super fast, and that's why. Is that enough?
How does this compare with Micronaut?
In Micronaut, how does it compare? They are using Netty, unlike us. They are reactive behind the scenes, right? So it gets really complicated when something goes wrong. And there is, if you are reading the security issues around the Netty, there is one every other day. It's a really great library, the Netty. I won't say it's not, right? But it's reactive by choice. It exists for a long time. It's one of the really great frameworks. But it creates this great complexity kind of bubble up into your applications anyway, even if you try to hide it behind imperative APIs. If you do that, you will lose that performance gain you got, by using the reactive or asynchronous library for I/O like Netty. So if you want to be really fast as Helidon in Micronaut, you have to use the reactive APIs. And if you use that, it's really complicated to actually maintain it. You don't have to do that in Helidon. You get that performance without any reactive hassle.